Hi there, everybody. In this section, we're going to keep going with Chapter 2, and we're going to look at box plots and the quantitative categorical relationship. This is really just another extension of the previous two sections that we've been doing. So let's jump right in. Nothing real fancy going on here. Okay, I'll let you read that. Let's just get right into the information. So the last type of graph we're going to see here is called a box plot. In earlier sections, we saw a histogram and a dot plot. Those are both very nice graphs. They give you a lot of detail. This graph is a box plot. Not much detail. In fact, they're kind of funny looking. And the way this works is this is just a picture of the 5-number summary. And what's nice about box plots is that it shows the general shape of the distribution. So we can see here that this is skewed left because we have outliers over here on the left. And outliers, if you have 3 outliers to one side, that's going to skew your distribution to the left. The box plot also identifies the middle 50% of the data. So this big box here is the middle 50%. And on the next slide, it kind of shows you how to build it. And again, shows outliers. So here's a breakdown of the box plot on the previous slide. So the way this works is you have your quantitative data value at the bottom. And the graph, the height of the graph does not have any meaning. You just mark all the observations just on this center line. And then when you get to the middle 50% of the data, so between Q1 and Q3, you just expand that and build a box out of it. So that's why it's called a box plot. So here's your 5-number summary, right? Maximum, Q3, median, Q1. The minimum is the smallest number in your 5-number summary. But because a box plot will show you outliers, what you do is you extend from Q3 all the way up to the maximum value, unless the maximum value is an outlier. Here, same thing, you extend from Q1 all the way down to the minimum, unless your minimum is an outlier. So if there were no outliers, this thing would come all the way down here. But because there's outliers, that line is not allowed to extend into the outliers because you have to identify them. So this line is just extended to the smallest value that's not an outlier. So if there were outliers on the right side, this would extend up to the largest non-outlier. So really, if there are no outliers, a box plot gives you the same information as the 5-number summary. If there are outliers present, it gives you a little bit of extra information. It tells you all of the outliers, and if there are outliers, it tells you the smallest non-outlier, whatever that value happens to be here, it's like 520. Or if there are outliers over here, it shows you the largest non-outlier. So kind of a weird looking graph, but very useful, and you'll see later on in the second example today why these things are really nice to use. So how do we detect outliers using box plots? So what we do is we use values computed from the 5-number summary. If you have homework that requires Q1, Q3, or the IQR, you have to use StatKey. I showed you guys that in the previous video, that real short video just on StatKey. For the vast majority of the homework, you're going to be given your 5-number summary and have to construct these endpoints for detecting outliers. So a data value is an outlier if it is smaller than Q1 minus 1.5 times the IQR or larger than Q3 plus 1.5 times the IQR. So that might seem like a really funny number, like where does this come from? This is just a formula invented by statisticians that seems to agree with the way data is presented in everyday life. I would say memorize this just because it's easier than looking it up. But I'll show you how to use this in the next section, or the next example. So here's our first example. So let's say we have a sample of size 500 and we know the 5-number summary. So remember what the 5-number summary is. Here's the smallest value, Q1, median, Q3, maximum. At the bottom, I've identified four numbers that were part of the data set. And we want to know, are any of these numbers outliers? You can see the minimum and maximum are both included, right? So if there are outliers, it's going to be one or the other of those, and maybe some others. So what we do is we use the IQR method for detecting outliers. So you have to compute the IQR first. The IQR is just Q3 minus Q1. In this case, it's 40, right? You're always given this stuff, or you use StatKey, or possibly a graphing calculator, depending on the situation. For the homework, you're going to be given these numbers, but for a test, you might have to compute them on your own, using the technique from the previous section. So what we do is we compute Q1 minus 1.5 times the IQR. So we're given Q1 as 300 minus 1.5 times, IQR is 40. Just type this whole thing into your calculator exactly the way it looks. You're going to get 240. So that's your left boundary. So any number smaller than 240 is an outlier. On the right side, you do Q3 plus 1.5 times the IQR. So Q3 is 340 plus 1.5 times 40. Type the whole thing into your calculator. You get 400. So any number bigger than 400 is also an outlier. So the way we summarize this is that any values outside of the interval from 240 to 400 are outliers. Well, we can go back and look at our initial numbers and see which ones are outside of this. 230 and 410 are both outside of this range given, so they're both outliers. 250 and 390 are inside the boundary, so they're not outliers. So if you were to draw box plots with this data set, you would see two little asterisks on the sides that would show you that the outliers are present. So on the homework, you have problems very similar to this, where you're given a big list of numbers and you have to decide which ones are outliers and which ones are not. Use this formula and then these two. On those homework problems, just remember how to do multiple choice on online homework. If your choices have circles, only select one. If your choices have little squares, you may select one or more. Some of these have multiple answers. So if it was a problem like this, you would check 230 and 410 as both being outliers. So make sure that you watch for that. This is just a quick note because we've now seen unusual observations from section 2.3, and now we've seen really sort of a quantitative way to identify outliers. And in the previous section, it was determined that an observation was unusual if its z-score was above 2 or below -2 for its z-score. Here, what we just saw is how to use quartiles to find outliers. And although unusual observations and outliers are similar ideas, they are not the same things. So don't mix those up. If you hear unusual observation, you're going to use the z-score method, where you just compute the z-score and determine if the z-score is bigger than 2, less than -2. If it's an outlier and you have to compute it, you have to use the IQR method that we just saw. It is possible that an observation is unusual and outlier, both or neither, depending on the overall shape of the distribution. So although they are related concepts, they're not the same ideas. A lot of terminology. All right, what we're going to see now is what happens when we have a quantitative response variable and a categorical explanatory variable. So many problems in statistics involve this combination of variables. So here's a couple at the bottom. Do men or women tend to watch more television? And does caffeine increase the speed of a person's finger tapping? So this first one, you can see that the categorical explanatory variable is gender. And the response variable is how much TV they watch per week or per month or whatever. So that's quantitative. And then this is an observational study. The second one would be an experiment, right? Where you'd have two groups. You'd have a group of people getting caffeine and another group who get placebo. So that's your categorical explanatory variable, is caffeine or no caffeine. And then the speed that a person taps their fingers is, of course, going to be quantitative. So what we're going to look at is sort of a geographical study about college degrees and region of the U.S. So suppose we want to investigate the possible connection between percentage of adults with a college degree and region of the U.S. So a couple of things I want to point out here. The explanatory variable would be region of the U.S. The response variable would be percentage of adults in each state with a college degree. Okay, so that's this is a little different than what we saw like earlier. We saw some studies where you would ask individual people questions like, do you have a college degree? And the response variable would be, yes, I have a college degree, or no, I don't. This is different. Here we're taking all the data and collecting it and averaging it and just calling that the percentage. So there's many, many ways we can use data. So here are some summary statistics. These are called comparative summary statistics. So even though it's not an experiment, it's comparative because we can just put the things side by side and look at them. And this gives us a lot of information. So let's go through and look at the information we're given. So in the Midwest region, there's 13 states, and you can see the states here, right? If you're not sure what state is in what region, this is a very unofficial region. This is just geographically the way it's done. Usually in the United States is the way it's broken up. So we can see the mean college degree rate. So what this is saying that on average, if a state is in the Midwest, 32.76% of adults have a college degree. Among the 13 states, the standard deviation is 3.66. The minimum college degree rate is 25.7. We don't know which state it is. And then you can see, here's your 5-number summary. So the 5-number summary tells us about skew. We can compute outliers if we want. And then here we have the mean and standard deviation. So you can kind of look at this and see what's going on. Like you can see one state in the Northeast has 48% of adults with a college degree. It's a pretty high rate, right? So you can kind of learn some stuff just looking at the numbers. So compute this. So for part A here, compute the difference between the largest and smallest means and interpret the results. Does this difference appear to be significant? All right, let's check it out. So the largest mean is in the Northeast. We can see that here. And the smallest mean is in the South. So you just take this mean minus this mean. And because these are populations, these are individual populations, we're going to use the notation of mu for population mean. So it's 37.96 for the North region or Northeast. I just put an N. And for the South, I put just a little S, it's 26.73. So it's 11.23. So the difference between the college degree rates of the two regions is 11.23 percentage points. And again, it's a significant difference because it's not close to zero, right? A small difference would imply the rates are nearly equal. So if both regions had a college degree rate around 38, then you would say it's not a very big difference. It's not a significant difference. But here, 11.23, pretty far away from zero. And now you're kind of thinking about this in terms of what we saw earlier when we did back in section 2.1, when we looked at the graphs. Next question. Which region has the most variability? So we have 3 measures of variability. So make sure that if you're looking at a homework problem that you're You're following what you're asked to do. Use the standard deviation as the measure of variability. And then I'm going to go ahead and talk about part C as well. So in part C, it says repeat part B using the IQRs of each region. Hold on, the Amazon truck's backing up outside. Hold on one sec. They like to turn around in my parking lot, I don't know why. All right, well, hopefully that super loud Amazon truck sound isn't bothering you guys. So for part C, we're going to do the IQRs of each region. So we have two different measures of variability here, right? Standard deviation and IQR. So we're going to see, do these two measures of variability agree on their value? Let's see. So we can see the standard deviation pretty clearly here, right? The Northeast has the largest standard deviation. Clearly, right? So the most variability if you measure standard deviation is the Northeast. What if you measure the IQR? So in order to measure the IQR, you have to go through and do Q3 minus Q1 for each of these regions. And it turns out that the West is actually the largest region. So 31.25 minus 24.15, here's your answers, right, is actually 7.1. So using two different measures, we got two different answers. That's okay. The standard deviation, remember, takes into account all the data values. The IQR uses medians. So the two numbers might not agree. That's totally fine. All right, let's keep going. Which region has the highest college degree rate? So we saw that the highest state in the summary statistics was 48, around 48, and it was right here. But that's not what this question is asking. When you see a question like this, this doesn't mean which region has the state with the highest college degree rate. It means on average, which one has the highest college degree rate. So we could go back and look at the means. We can also look at the medians. We have a box plot in front of us. We might as well just use the medians because the medians are these vertical lines in the box plots, right? So the highest median is going to be in the Northeast. Again, we could use the means if we wanted to. If you want to flip back, you might get the same answer, you might not. Here, we're just going to use the median, right? So let's go back and look at the means, right? 37.96, right? We computed that earlier. Okay. Which region has the most variability in its college degree rate? Well, we saw the Northeast has the highest standard deviation. The West has the highest IQR, and there's one more measure of variability. The range is another measure of variability, and so that's what it says here in part E. The Northeast region has the highest standard deviation, the West has the highest IQR, but the Northeast region has the largest range. Depending on which measurement is used, they can both be said to have the most variability. Remember, when you use the range and standard deviation, if outliers are present, it can affect the results. So maybe there's some outliers present. So it's okay that these things don't agree. I just want you guys to understand that you can go through a data set and pull out lots of different numbers and learn lots of different things. All right, describe the shape of the distribution for the South. So here is most of the data values in the South. And then we have this one observation way over here on the right. So this is going to be skewed to the right because we have an outlier on the right. Gee, which state is the outlier? I'm going to let you guys think about that one, and hopefully you can put some questions up in the discussion forum. I'm not giving this answer away. I want you to think about, why we use graphical descriptions. Maybe there's something about this state that's telling us that maybe it should belong in a different region like this one, right? Because this state, whatever it is, has a higher college degree rate than any state in the Midwest, any state in the West, and any other state in the South. Maybe this state belongs in the Northeast. So think about what a state would be that belongs in the Northeast. Possibly. And maybe you can guess the answer. Last one. Does there appear to be an association between college degree rate and region? So this is the question we've been trying to answer. Whenever we have two variables, we're looking for an association. So what does that mean? Well, if there's no association, then all of the graphs and summary statistics should be about the same. But these graphs all look very different. The summary statistics all look different. So that means there is an association. What I put for my answer here in part H is that we only need to use one measure of difference for the association. You're allowed to use any measurement you want, but the only one we're going to focus on in this class to any serious extent is the difference between the means, what we did in part A here. So the difference between the means is large. We conclude a significant association exists between college degree rate and region. You're allowed to use the shape of the distribution, the standard deviations, but we don't go into any detail with that. But some of you might end up taking other stats classes later, and you'll see that there are many, many measures of association. For the rest of this class, we're only interested in the difference of the means. And that leads us to this slide here. So problems like example 2a are called difference of means problems because they involve subtracting means from two different samples or populations. It doesn't matter if you're doing samples or populations. Computing a difference of means is one of the measures of association between a quantitative response variable and a categorical explanatory variable. There are actually many measures. If the means are too similar, then we cannot conclude that an association exists between the variables. And so if the numbers are very similar, when you subtract the means, you will get a number close to 0, which tells us there either isn't a difference, or if there's a difference, it isn't very big, so it's not significant. Right, well, that's the end of the section. Nice short section for you guys. As always, if you need extra help, here's your extra practice. And don't forget that you guys can always ask questions in the discussion forum, or you can email me. So until next video, study hard, and I'll see you later. Bye-bye now.